Yes, you are still at TB Talks. Of course, it is continually bringing you more information and more. This time, let's see how independent assortment causes variation in organisms. So, we are dealing with one by one. One by one. We started with the crossing over, and then this time we are dealing with how independent assortment causes variation in organisms. Dear scholars, you will need to agree with me that independent assortment occurs during meiosis in a phase called metaphase 1. And of course here, during independent assortment, during metaphase 1 of meiosis, so what happens is that chromosomes in the form of homologous chromosome pairs or bivalents orient randomly at the spindle equator. They just orient there. Okay? In other words, orientation redirects to positioning. They just position themselves at the metaphase plate randomly. Okay? And now, of course, during anaphase 1, what happens is that the bivalence separates independent of others, or homologous chromosomes now separate independent of others. So now, what happens or what follows? So, after separation, the homologous chromosomes can now move to opposite cells, and eventually during cytokinesis, which is the actual cell division, what happens is that we shall have gametes comprising of chromosomes that carry different genes, and thus eventually causing variation in organisms. Okay? Otherwise, the word independent assortment means rearrangement. Okay? It means rearrangement. So here we can say that the random orientation, the orientation of homologous chromosomes, These ones organize in form of bivalence. In form of bivalence. Okay. The orientation, this is the letter T, the orientation of homologous chromosomes in the form of bivalence. During metaphase 1. During metaphase 1 at the spindle equator. Okay? During metaphase 1 at the spindle equator, or metaphase plate is random. Okay, that is where we are. The order of the way the chromosomes in form of bivalence position themselves at the equator of the spindle or the metaphase plate, of course, briefly, is random. there is no order followed. It is random. Okay, this word is very important. It's random. Then what follows? What follows is that now, during anaphase 1, the other stage which follows metaphase, what happens is that the bivalents separate independently of others. Okay? The chromosomes or the bivalents, the homologous chromosomes, the homologous chromosomes, homologous chromosomes in bivalents, or we say the homologous pairs. Okay, that one will sound better. The homologous pairs of chromosomes, which we call bivalents. The homologous pairs of chromosomes or bivalents separate independently, of others. Okay? So, the homologous pairs of chromosomes or bivalents separate independently of others. They separate independently of others, leading to new gene combinations. Leading to new gene combinations in gametes. Which lead to formation. We say production, which lead to production of recombinants offspring. That is enough. Even if we say hence leading to variation in organisms, it is already here. The thing is, how does it lead to genetic variation? So, that is how independent assortment, of course, briefly, cause variation in organisms. We say the orientation of homologous chromosomes in the form of bivalents. Okay? That is a point. In the form of bivalents during metaphase 1. Okay? During metaphase 1 at the spindle equator or metaphase plate. Or metaphase plate is random. Okay? Is random. That is what is happening. That the orientation of homologous chromosomes in the form of bivalents. So there is a point there. During the metaphase 1, okay? Another point. During the metaphase 1, we put a point here. At the spindle equator or metaphase plate is random. The homologous pairs of chromosomes or bivalents separate independently of others. Independently of others, leading to new gene combinations in gametes, which lead to production of recombinant offspring. So that is what happens, and that is how actually independent assortment cause variation in organisms. Now, independent assortment means, okay, independent assortment of genes. So I can say that in being independent assortment of genes means rearrangement of alleles during metaphase 1, during metaphase 1 of meiosis 1 to form new allele or gene combinations that lead to variation in the offspring. So the word independent assortment simply means rearrangement of alleles during metaphase 1 of meiosis to form new allele or gene combinations that lead to variation in the offspring. Okay? So it occurs at the spindle equator. So, dear scholars, that is how independent assortment causes variation in organisms. Let us meet another time.